Hi, welcome to this STAIR Tailored. I'm Sarah Powell from the University of Texas at Austin. And today we're solving one-step equations, and we're going to look at the equations in this STAIR Tailored that have a subtraction operator symbol, so those that have a minus sign. So we're going to solve equations like x minus 3 equals 2, and right now we're going to use the Algeblocks. Now, the Algeblocks are a really cool tool that you can use to help students understand different algebraic concepts to solve different types of problems like this. And the two concepts we're really going to emphasize today is the first concept is zero pairs. So if I have a positive and a negative, those equal 0. They create a zero pair. So we can use zero pairs, we can create zero pairs and remove them from our algebraic equations. We can also bring in zero pairs to our algebraic equations. We're also going to really emphasize what happens when we have this symbol right here, the equal sign. Whenever we do one thing to one side of the equal sign, we have to do that same thing to the other side of the equal sign. We really need to emphasize the equal sign as a balance. So let's look over at our document camera of how we can solve these two equations using our Algeblocks. So as I'm using my Algeblocks, I have a few things. I have my Algeblocks out here. With my Algeblocks, these yellow rods, these represent my variable. And today I'm going to use those to represent x, but you could use them to represent any variable that you want. And then my green cubes, these represent my constant. So each of these have a value of 1. We are going to solve these equations here, and because I have an equal sign and I need to balance the sides of the equal sign, I use this Algeblock sentences mat. Has an equal sign in the middle, and it also has this little balance down here that helps me remember we need to balance the sides of the equation. So let's go ahead and get this set up. I start with x, and that x is positive. And I have to subtract 3. Now, a lot of you are probably really tempted to just go ahead and put 3 cubes down there, and that is correct. But one thing your students may want to know is why that works, and this might be important for initial instruction. So I have to think, I need to subtract 3, and that's positive 3, because this is a subtraction symbol, and there is no negative symbol directly in front of the 3. So do we have 3 positives to subtract? No. So we can use zero pairs. If we bring in a zero pair, it does not change the value of what we have going on here right now. I could bring in another zero pair, still hasn't changed the value, and a third zero pair. Now we have 1, 2, 3 positives that we can subtract. I'm going to go ahead and subtract those by moving them off the mat. And so now we have x minus 3. That's how we get that initial setup. Now again, you may not want to do that every time, but in initial instruction, that might be an important thing for you to show. And then on the other side of the equal sign, we have 2, and that's a positive 2. Now we want to isolate this variable. So that means I'm going to leave this x where it is, and I want to move this constant to the other side of the mat. Now to do that, I can use my zero pairs. If I bring in 3 positives here, that would create 1, 2, 3 zero pairs, and that would make this side of the equal sign equal 0 in terms of the constant. So that's fine to do. But if I brought in positive 3 to this side of my mat, I also have to do the same thing on this side of the mat. Remember, whatever you do to one side of the equal sign, you also do to the other. Now I'm going to leave this right here for just a minute, and I'm going to think about how the abstract form of this problem is going to match all these cubes and all this messiness we have going on, excuse me, right here. So let's set up this problem. X minus 3 equals 2. I want to balance these two sides of the equation, and I want to isolate this variable. To isolate this, if I have minus 3 or negative 3, I'm going to add 3, but whatever I do to one side of the equation, we have to do to the other side. So then if we look at this right here, this is exactly what we have set up with our manipulatives. X and minus 3 plus 3, so that will cancel to 0. And then I have 2, and then I added my 3. You want your use of manipulatives to mirror what the abstract form of the problem is doing, both conceptually and procedurally. So here I have that equals 0, so x equals 5. And how does that happen? Well, let's see, I have 1, 2, 3 zero pairs. I remove those. And here I have, no zero pairs. So x equals 5. And that's what we solved right there with the abstract form of the numbers, and we did the same thing with the concrete form of the numbers. Now quickly, let's do this next problem here. 5 equals x minus 2. I start with 5, it's positive, I place it here in the positive part of this mat, equals x, that x is positive, minus 2. I'm going to place that down there, but remember I could always go through, well, what does it actually mean to subtract 2 when you don't have positive 2 to take away? Now we want to isolate that variable. I'm going to use my 0 pairs to help me do this. So let's see, I need to make 2 0 pairs here, which means I need to bring in positive 2. But if I do bring in positive 2 to that side of the mat, I have to bring in positive 2 to this side of the mat. I create my 0 pairs and remove them. X equals 7. Oops, that was bouncy. X equals 7. And if I plug that in, 5 equals 7 minus 2. Cool, we answered that problem correctly. So those are just 2 examples of how we can use those Algeblocks when we are solving simple one-step equations that have a subtraction operator symbol in them.